A lampshade is made in the form of the lateral surface of the frustum of a right circular cone. The height of the frustum is 3√3 inches. So let's draw the height. Its top diameter is 6 inches. Therefore, the top radius is 3 inches. And its bottom diameter is 12 inches. So the bottom radius is 6. A bug is at the bottom of the lampshade, and there is a glob of honey on the top edge of the lampshade, at the spot farthest from the bug. The bug wants to crawl to the honey, but it must stay on the surface of the lampshade. What is the length in inches of its shortest path to the honey? So in order to visualize the surface of the lampshade, let's extend the frustum so that it forms a cone. We know that from deriving the surface area of a cone, if we were to unfold the cone, we would obtain a sector. So by looking at similar triangles, we see that um, the height from the center of the top base to the apex is 3√3. So therefore, the height of this cone, if we were to extend it, would be 6√3 inches. Now, because the bottom radius, which is the base radius of this cone, is 6, this means that the slant height would be 12 inches. So therefore, if we were to unfold the surface of this cone in order to obtain a sector of a circle, we would see that the radius would be 12 and the circumference of the base is 12 pi. So therefore, the lateral surface forms half of a circle of radius 12. Now, keeping in mind that we have to exclude the top cone of base radius 3, so the surface is actually going to look like this, where we exclude the innermost semicircle of radius 6. So something like this. Now we need to figure out where the bug and the honey are on this semicircular annulus shape. Let's place the bug at one point, let's say this point right here. Now we need to figure out where the honey is relative to the bug. Clearly the honey has to be on this semicircle. However, note that the honey cannot be at this point H. The reason why is because the two straight edges are going to be joined together, and if we were to do so, we would see that the bug and the honey are actually close to each other. So instead, the honey actually has to be at the halfway point, which is this point. So now the problem reduces to finding the length of the shortest path from B to H, which is going to be this path drawn in red. So you can think of it like stretching a rubber band whose two endpoints are B and H. You will see that this path is going to be straight and then tangent to the circle. So let's draw the tangency point, call it P. And since we know that the inner radius of this lateral surface is 6, you see that BP is 6√3. And that's if the center is O, triangle BOP is a 30, 60, 90. Next, in order to find the length of arc PH, we can note that angle POH is 30 degrees. So the length of arc PH will be 1/12 of the circumference of a circle with radius 6. This is equal to pi inches. So therefore, the length of the path from B to H, by adding up these two quantities, you get 6√3 plus pi inches. Now, looking at the answer choices on the next slide, we see that this is answer E.